Okay, so now we're going to fill out this table right here. So we are investigating how does changing the launch height, which is the vertical displacement, how is that going to affect time? Okay, so I've set up the table already, 3, 6, 9, 12, 15, because that's going to help answer some questions later on in the lab. So let's go to PhET, and don't forget I set my initial launch velocity at 15 meters per second horizontally. So let's go check this out. You can just type in PhET projectile motion. Before I even get too far, it pops up. I'm going to hit play and go right to the lab. And I'm going to first raise it up to 3 meters. I need it to be a horizontal launch. And my speed was 15 meters per second. And I'm going to keep that constant for all my launches and keep modifying the height. So it doesn't matter what I'm launching. I'll just leave it as a cannonball. I want to make sure air resistance is off. Gravity 9.81 meters per second squared. Let's go ahead and launch. Now, to measure how far it went, we could use this, but what we're collecting is information on how long it was in the air. So we need this guy right here. Drag it on down and place the plus sign, the crosshairs, right at the dot where it hits the ground, and we get 0.78 seconds. So I'd come back into my lab and say, okay, when the launch height was 3, and this is meters, right? Don't forget your units. I get 0.78 seconds. And then I'm just going to go and finish collecting data. So then I'll increase my height to 6. And then I see it was 1.11 seconds. Then I'll go up to 9. I get 1.35 seconds. 12 meters. 1.56 seconds. And finally, 15. 15 meters is the max height for this lab. Now, if you're getting off the screen a little bit, you can zoom out. Upper left-hand corner, there's a zoom plus or minus. And I'm getting, well, it's harder to get the values when you zoom out. 1.75 seconds for 15 meters. 1.75. All right, and you might notice these values are not decreasing at a constant rate, so this is not going to be linear. So we're going to graph our data using Desmos. There's a link right here, or you can use Quick Graph. Quick Graph is super fast, so let's use that. 0.78, 1.11. So our X, make sure you title your graph. Our X, our input was vertical displacement. Or you could say the height of the tower. All right, and our and then our, you know what, let's be technically correct, because vertical displacement would be negative. So we don't want any negative values on the x-axis. So let's just write height. The magnitude, the height is the same thing as the magnitude of the vertical displacement. So we'll just write height in meters. And then our y-axis is time measured in seconds. Okay, and our heights were 3, 6, 9, 12, 15. And our times were 0.78 seconds, 1.11 seconds, 1.355675, 355675. Okay, so now I've got my graph, and I'll go to get a curve fit, and it doesn't look proportional to me. It doesn't pass through my points. Linear is pretty close, but the square root function is going to pass through all the points, including 0, 0, which makes sense. If my launch height was 0, it wouldn't take any time to reach the ground at all. So that's why linear is not a good solution. It does not pass through 0, 0, and 0, 0 is a logical answer. Now I'm going to take a screenshot of this. I'm going to crop it so I can see everything really well. Make sure I get my labels. Done. Then I'm going to come back in and insert a screenshot of my graph. You can use the T to drag it into place. And then we're good to go. And the question, does my variables form a proportional relationship? Well, proportional would mean that it passes through 0, 0, and it's linear, right, on my graph. This is proportional. My graph is clearly not proportional, so the answer is no.